At 4:15 a.m., a single Ukrainian drone launches on a one-way mission into Russian territory. Its target? Russia's largest military drone factory, producing 500 attack drones every month that devastate Ukrainian cities. The drone will fly for 10 hours, covering 900 kilometers through Russian airspace defended by GPS jammers, S-400 missile systems, electronic warfare stations, and 14 dedicated anti-drone systems. It has no satellite link, no remote control, no way to be commanded from Ukraine. If successful, it will destroy 6 months of Russian drone production worth $500 million. If it fails, nothing changes. This is the true story of how one autonomous drone defeated Russia's most sophisticated air defenses by doing something nobody expected. It stopped listening. The mission almost ends before it begins. At 4:19 a.m., the drone crosses into Ukrainian airspace 30 seconds from a friendly air defense position. A Ukrainian Gepard anti-aircraft system locks onto it immediately. Twin 35mm cannons swivel to track. The fire control computer shows 94% hit probability, 8 kilometers range, and closing. The operator stares at his scope. The profile matches a Bayraktar TB2 drone, but Russia had captured TB2s before and turned them against Ukrainian forces. One had struck near Bakhmut last month using this exact approach profile. His finger hovers over the fire button. At this range, his tungsten rounds would shred any drone in seconds. Then he remembers the midnight briefing. From 0420 to 0430 hours, do not engage aerial targets at 150 meters altitude, plus or minus 5, traveling at 150 kilometers per hour through these exact coordinates. No explanation, no context, just strict orders. His watch shows 4:19, 1 minute until the window opens. 4 kilometers and closing, every instinct screaming to engage, but those parameters match perfectly. Exactly 150 meters altitude, exactly 150 kilometers per hour, exactly through the specified corridor. Through his optics, he sees it clearly now. Not a Bayraktar, an AN-196 loitering drone, Ukrainian-made, Ukrainian mission. The Ludi passes overhead at 4:26. The operator watches it vanish into Russian territory. Morning reports will soon cascade through Russian command about a drone that can't be stopped. By 6:30, Russian Sector Command in Bryansk receives 3 anomaly reports. Observation posts along the border report the same contact. Slow-moving drone, 150 meters altitude, heading 087 degrees, not responding to electronic challenges, not deviating from course. The tactical display shows a straight line toward Nizhny Novgorod, and from there the projection continues directly to Alabuga. The duty officer orders immediate deployment of the Pol-21 GPS jammer to intercept. The Pol-21 is Russia's premier GPS denial system, a mobile broadcasting tower mounted on a military truck with a 15-meter antenna mast radiating 1,000 watts of electronic noise on both GPS frequencies. It creates a 20-kilometer bubble where satellite navigation ceases to exist. The signal strength hits drones at -90 dBm, while real GPS whispers at -130 dBm. That's 10,000 times stronger, like trying to hear a whisper next to a jet engine. The drone enters the jamming zone at 6:34. Russian operators watch their scopes, counting down the expected sequence. 3 seconds for jamming to overwhelm the receiver. 5 seconds for the drone to recognize signal loss. 10 seconds to begin lost link protocol, usually circling or returning home. At 8 seconds, the drone wavers slightly as inertial navigation compensates for lost GPS. At 10 seconds, it should turn. It doesn't turn. It steadies and continues east. The operator switches to spoofing mode. Now the Pol-21 broadcasts false satellite signals that convince any GPS receiver it's 500 kilometers from actual position. The drone should start correcting toward this phantom location, gradually flying off course until fuel exhaustion. The Ludi ignores the false signals completely. Analysis of its flight path reveals something sophisticated. The drone isn't simply following one landmark. It's using multiple terrain references. Follow the M3 highway for 10 kilometers. At the distinctive S-curve near Selzo, adjust heading 15 degrees north. Track power lines until they intersect the river. Cross at the 3-span bridge, not the 2-span. Each waypoint chosen for uniqueness. impossible to confuse. Visual navigation means complete autonomy. No GPS to jam. No control link to override. Russians have spent $8 million per Pol-21 unit, thousands of engineering hours perfecting GPS denial. Ukraine defeats it by teaching the drone to look where it's going. The alert goes to Nizhny Novgorod's S-400 battery. Drone inbound. Estimated arrival 9:45. By 800 hours, Russian electronic warfare operators are tracking something that shouldn't exist. A drone navigating precisely through GPS darkness, following highways, rivers, and power lines like a tourist with a perfect map. Each checkpoint bringing it closer to Alabuga, where 5,500 Shahed drones wait in warehouses before deployment over Ukrainian cities. At 9:45, the S-400 battery near Nizhny Novgorod has been tracking anomaly reports for 3 hours. Their 92 N-6E gravestone radar should find it easily. This radar contains 10,000 transmit-receive modules pumping 100 kilowatts of focused energy. Against a fighter with 3 square meters of radar cross-section, detection range reaches 250 kilometers, but the AN-196 presents only 0.5 square meters, 6 times smaller than a fighter. That mathematics collapses detection from 250 kilometers to just 107. Worse, the drone flies at 50 meters altitude, using Earth's curvature as a shield. At 9:45, the drone climbs briefly to 200 meters to clear terrain. The radar locks on immediately. Slow-moving UAV bearing 262, range 89 kilometers. The classification is unmistakable. 12-meter wingspan, twin-boom configuration, possible Turkish Bayraktar. But the location is impossible. Turkish drones have 300-kilometer range. This contact is 900 kilometers from Ukraine. The timing couldn't be worse. Shift change at 1000 hours. The overnight crew has 13 minutes left, already mentally checking out. The day crew won't be fully oriented until 10:15. This 15-minute gap is where nobody wants to make critical decisions. The track shows a perfect straight line toward Alabuga, not the wandering pattern of reconnaissance, not the searching behavior of surveillance. This is arrow-straight navigation to a specific target. Here's where the S-400 Pantsir relationship becomes critical. The S-400 handles long-range threats with its 48 N-6E missiles, $2 million each, designed for high-value targets. The Pantsir provides close-in protection with 30mm autocannons and smaller missiles. They work together, sharing radar data, creating overlapping fields of fire. But the system has a geometric flaw. The Pantsir's guns can't depress below -5 degrees. At 4 kilometers range and 50 meters altitude, the angle needed is -7 degrees. The drone is literally flying under the guns. The expensive missiles are doctrinally reserved for larger threats. The cheap autocannons can't reach it. The contact descends back to 50 meters, vanishing into ground clutter. Ground clutter is radar's blind spot. All the reflections bouncing off trees, buildings, hills, creating noise on the screen. The drone vanishes into that chaos like a needle in a haystack. At 11:47, Alabuga's counter-drone station has been tracking the inbound threat for hours. Now it's here. 8 kilometers out, climbing through 250 meters, flying straight at them in broad daylight. The Repellent 1 system activates, purpose-built to stop drones. That directional antenna focuses 500 watts into a 30-degree cone, overwhelming any drone receiver within 2.5 kilometers. The system's computer contains 10,000 command protocols. Every frequency, every standard, every override command ever used by drones. Turkish military frequencies, NATO standards, Ukrainian protocols, even Chinese commercial codes. 500 watts of electromagnetic energy slams into the drone, cycling through all 10,000 commands in 4 seconds. Return to home. Land immediately. Enter hover mode. Switch to manual. Emergency stop. Every possible override transmitted in every possible format. The AN-196 flies on unchanged. Straight, level, mechanical. At 11:52 high noon, The AN-196 punches through the anti-drone mesh at 180 kilometers per hour. The steel grid designed for 5-kilogram quadcopters shears instantly against 700 kilograms of aircraft. The thermite warhead penetrates the warehouse roof. Iron oxide plus aluminum equals 2,500 degrees Celsius molten metal streaming into stored Shaheds. The first fuel tank ruptures in 0.3 of a second. 2 seconds, 50 drones exploding in sequence. 8 seconds, roof structure failing. 15 seconds, north wall blown outward. 30 seconds, all 5,500 Shaheds consumed. The fireball climbs to 800 meters. Overpressure shatters windows 5 kilometers away. 6 months of production, $500 million of Iranian technology vaporized in under a minute. One long-range drone proved that in autonomous warfare, all the sophisticated defenses are just expensive systems shouting at a drone that can't hear them. Subscribe to see how modern technology is reshaping warfare, because the rules just changed forever.